Alright, 3.5D, last video in section 3.5 talks about the point slope formula and really kind of summarizes, and not just point slope formula, but it kind of summarizes different forms of linear equations. So we're going to fast forward to our last slide in the, last slide here. So here's a summary of different forms that linear equations may take. So the standard form was kind of, ax plus by equals c. And you know what? Okay, well that kind of gives you some information. Here's an example. A and b must not both be 0. One could be 0, because then you throw away this term here, maybe in y equals something. Or b could be 0, and you throw away that term, and x is something. So if that's true, then we've got y equals k is a horizontal line. Remember, horizontal line, if we've got something like that, horizontal line would be something like that. There's our horizontal line. Remember, we've got the, if we take a look at y, we can say that y, if you flip it around, kind of looks like this. Kind of looks something like that. And then you got to say, oh yeah, horizontal line, because of that funny looking y term. Or if you've got a horizontal line, you can always say, oh, that h kind of looks like a y, so that means that y equals some number, means it's a horizontal line. And here's an example, y equals 4. And remember, the slope is 0. For something like this, the slope is 0. Because if it's y equals mx plus b, kind of like down here, the slope is 0. That means that x term would go away, so therefore we just have y equals some number. So the slope is 0, just like our bunny hill. Slope is going to be 0. You kind of got to push yourself along, and then the y-intercept is at x equals 0, and k is our b point. In other words, where that point right there is, that's k, because our y equals k, and therefore all the values for y are equal to k, including our y-intercept. For a vertical line, we've got x equals k. Well, here's an example. There's our axes, and here's our, I'll make this green. We've got a vertical line, then we've got a vertical line like that. And that's a vertical line. X equals some constant k, because all the values here, all the points here, have x equal to that constant k. And in the example, it's x equals -1. All the values are -1. Actually, for x equals -1, it should be on the other side of the axis, but because I wrote it down here, I will just use this green line. All the values for x are going to be the same value, and the y could be whatever it wants to be. So x equals k is a constant, and remember the slope is undefined, because if you're looking down the slope of that green line, you look over your skis and you say, holy cow, that's not a slope, that's a cliff. So there's no slope there, that's undefined. And then the x-intercept is at k 0, because all the values for this, all the x values for that line are that k value. In this example, it's -1. This example doesn't hold really well, because -1 should be, like I said, on the other side, but all the values are the same here, including that x-intercept right there. Slope-intercept form would be the one that I would say that is going to be always going to be our goal. It's going to be our goal. Every time that we have a line, we're going to try and write it into slope-intercept form, because it gives us so much information. It gives us the slope, and it gives us the y-intercept. And from that y-intercept b, we can use that to say, well, we're going to graph our first point, and then after we graph our first point, we can use the slope to create another point, and we can make a line. So if we solve for y, 1y, then we get the slope-intercept form. Everything else is on the other side. The number in front of the x is the slope, and the coefficient here, the b term, it gives us our y-intercept. And then point slope formula as well is going to be very, very, very important, especially when we've got those 3 different situations that we talked about in this section 3.5. If we've got a point and a slope, if we've got 2 points, if we've got parallel or perpendicular, or if we want to create a parallel or perpendicular line through another point that's not on a line, that given line, then we can use the point slope formula. This information we fill in, that information we fill in, and that information we fill in, and then we solve for y equals mx plus b. Gives us information. So here's an example. Slope is -3. Our point x1, y1 that we want to create the line through is 4, 2. Well, here's our x1, goes right over there. Y1 goes right over there. Slope of negative 3 goes right in there, and then from here we solve for y equals negative 3x plus 14, I believe. I think that's, I'm going off the top of my head there. But this formula can be used to kind of build an equation to create a name for a line when we've gotten some information about the line and we want to create that line. So there's kind of a summary.